Hello and welcome to our first webinar of the year for the TAACCCT evaluation. I hope wherever you're calling from it's spring or something like it. Before we start our program, my colleague Debbie Silla will give you a technical overview of the webinar. Debbie?
Hello everyone, thank you for coming. We just want to remind everyone to please mute your phones upon entry. We're also going to be muting on our end too. This just helps us to contain some of the background noise as our presenters speak today. This webinar is being recorded and will be made available via SharePoint after the conclusion of the webinar, so you'll be able to access it later on as well. If you find that you need WebEx support, please call 1-866-229-3239. And if you need support during the webinar, you can also use the chat box, which is located on the bottom right of your screen. And so we're going to start the PowerPoint presentation here in a minute, but you can locate the chat box at the bottom right of your screen. And throughout the webinar, if you have questions that you would like the presenters to address towards the end, you can also include all of your questions there. Thank you.
Thank you, Debbie. If this is your first time joining us, welcome. This webinar is part of a series of learning events organized by Jobs to the Future with the Urban Institute, which is directing the national evaluation of the TAACCCT grant. Our goal is to share evaluation knowledge and resources and build a learning network to strengthen the local TAACCCT evaluations. We offer both webinars and roundtable conversations on topics of interest to the evaluation community for TAACCCT. So, today's webinar topic is understanding sample sizes needed for impact analysis. We picked this topic because we need to know if our TAACCCT programs made a difference for participants. So the evaluations are required to carry out a rigorous impact analysis, one that ideally can determine the size of a program's impact on participants. We know this isn't always simple in the real world of evaluating. We know from looking at the evaluation plans and talking to evaluators that there's a wide range of impact evaluation designs being conducted with varying sizes of treatment and comparison groups, which is what you'd expect given the variety of training programs, student characteristics, access to data for comparison groups and treatment, among other issues. So it's not always clear if there's enough statistical power in the sample to detect effects. To help address this challenge, we've asked two subject matter experts on this topic to share their knowledge of power analysis and sample size. First up, Bert Barnow of the National Evaluation Team at George Washington University. He's going to give you an overview of sample size issues for impact analysis and how to determine whether you have enough statistical power to detect program effects on participants. He'll go over the theory and the techniques for finding minimum detectable effects. After Bert, Greg Compton, a TAACCCT evaluator himself, and a research associate for the Ray Marshall Center at the University of Texas, Ray Marshall Center for the Study of Human Resources, will walk you through some practical examples from TAACCCT evaluations using statistical power analysis. I expect we'll have a lot of questions for our experts, so we'll be sure to allow a good amount of time for discussion. Now on to Bert.
Thank you, Randy. I'm very pleased to be with you all today and to talk a little bit about some of the sample size issues in your evaluations. I'm going to start. The first slide here shows some information that goes back to the solicitation that came out, the framework of preferred evaluation methodologies. Basically, you were all encouraged, if you could, to use random assignment to do a randomized control trial or experimental design. And the only time when that's not something you want to do is if you have a lot of your participants are going to be TAA eligible, because you're not allowed to randomly assign those people. So if it's not too late and you can go switch to a random assignment design, we would all encourage you to do so. And the second broad approach is using a comparison group cohort design or quasi-experimental or non-experimental design. And in this approach, you set up a comparison group of people who's not selected at random, but ideally is closely matched in a number of ways to people who are getting the treatment. So that's a second best strategy. And in this kind of design, again, more people is better than fewer, so we'd encourage you to get as large a sample as you can. And these are outlined in the solicitation for grant awards in Appendix H, in case any of you want to take a look at that. Okay, this slide here, slide 6, shows the planned evaluation methods that our grantees picked, and a number of the proposals suggested they were going to use multiple ways, so the numbers don't add up necessarily here. But we had 7 that were bravely going to try and do random assignment. I hope the numbers increased, although it may have decreased. And then we had a number of different non-experimental designs proposed. Some were planning to use a regression discontinuity design, which we won't discuss today. A number of others were going to use propensity score matching, and then the largest group said that they would do a comparison group design, but at the time they submitted their proposal, they weren't quite sure how they were going to pick their comparison group. So I would like to encourage you to, if you're in that group of 56, make sure you've figured out how you're going to pick your comparison group and use as rigorous a method as possible. One thing I'd like to add is before I turn to the specifics on minimum detectable effects, is that this approach to figure out the optimal sample size, or what you can get for a given sample size, assumes that you've already selected your comparison group or use in the best possible way. If you pick people who are not well matched in a comparison group approach, you may have a nice low minimum detectable effect, but you're likely to get biased estimates. So pay careful attention to how you get your comparison group, and that's a matter for another day, but it's an important caveat for all the things that are going to follow right now. Okay, I want to first talk about some of the basics in terms of statistical power and MDE issues. And I know we've got mostly evaluators on here, so for some of you, this will be just reviewing things you know really well. But in hypothesis testing, it's important for us to avoid the 2 types of errors you can make, which were creatively called type 1 and type 2 errors. A type 1 error is when we reject the null hypothesis, that's the hypothesis that there's no impact of the program, when it's actually true. And the other type of error, type 2 error, is when we do not reject the null hypothesis when it is actually false. That is, we're unable to reject the hypothesis that there's no impact when in fact the true effect is not 0. And this is what the type of error that we worry about when you have a small sample. You're unable to reject the hypothesis that there's no impact of the program when in fact there is an impact, and the reason we can't reject that hypothesis typically is we have too small a sample for the circumstances. Typically, we worry about type 1 errors more than we do type 2 errors. And we set the maximum type 1 error, and we usually refer to that as alpha at 0.05. In some of the social science literature, people alternatively use 0.10 or sometimes even 0.01. But 0.05 is by far the most common. With small samples, as we have in many of the TAACCCT sites, as I mentioned before, there's a high risk of making a type 2 error. And that's something we're going to discuss later today as we go through these examples. If you have a small sample, there is a risk that you'll be unable to determine with a reasonable amount of statistical certainty that it's not actually 0. So that's the type 2 error. We have a term we use in statistics called power, and that's defined as the probability that for a specified value of the true impact, we will reject the hypothesis that there's no impact when in fact it is false. And power in a given case depends on the actual impact, the sample size we have, and the size of alpha that's selected. And I should add as well also on whether we have one-tail or two-tail tests. And there are no absolute rules on the levels for type 1 and type 2 errors, but there are some rules of thumb that are commonly used. Typically, as I mentioned, the type 1 errors are selected to be 0.01, 0.05, or in some cases 0.10. For power, the most common levels of power we like to achieve are 0.7 or 0.80. So those are the most common examples. Okay, so now I want to talk specifically about minimum detectable effect or MDE. This was a concept developed by Howard Bloom, who's a researcher at MDRC in New York City, and it was to help evaluators select the most appropriate sample size and see what size impact we can likely obtain statistically significant impacts for when the program actually does have an effect. And the MDE is defined as the smallest true impact that would usually be found to be statistically significantly different from zero with specified levels of significance and power. And so basically the whole point of doing these MDE calculations is it takes power calculations, puts them into a relevant form that helps you figure out if you have a large enough sample or how big a sample you need to get a good enough sample. As I mentioned, the concept was developed by Howard Bloom, and it's in a 1995 article that appeared in Evaluation Review. And Larry Orr, in his book on experiments, also goes into a little bit more detail and a little less technical on how to compute MDEs. We have several articles on the SharePoint site that you can review information about minimum detectable effects. And as I mentioned briefly before, you can use these MDE formulas for two different purposes to determine how big or how small the MDE is for a given sample size, or to determine the sample size that you need to produce a small enough MDE that you'll be likely to get significant findings. In the formulas that I'm going to show you on the next couple of pages, there's a term called Z, which is a constant or multiplier, and that is determined by the levels of alpha and power that you've selected, whether it's a one-tail or two-tail test. And the most common figure for Z is this 2.80, and that's for a two-tail test, 80% power, and 0.05 alpha. Okay, so this next page, slide 13, shows the formula for minimum detectable effect when you have a binary outcome. By binary outcome, I mean, for example, we might want to look at whether people are employed or not in the post-program period, or whether or not people obtained credentials. So our dependent variable in this case is either yes or no. And the formula, which took me a long time to type, includes this multiplier that I mentioned, and we have posted on the SharePoint an MDRC article that gives you the various values for that variable Z depending on your significance level, your power level, and whether it's a one-tail or two-tail test. So it's Z. The next variable in there is the proportion of the study population with a successful outcome, so it would be somewhere between 0 and 1. And then the R square, which is the explanatory power of the impact regression, and that again will range between 0 and 1. And P is the proportion of sample members randomly assigned to the program group, and N is the total number of people in the sample that you're analyzing. And if you plug this formula into a spreadsheet, and we do have a sample spreadsheet posted on SharePoint, you can then either, for the given values of all the parameters you want to solve for one, you can either solve for the minimum detectable effect if you know what the sample size is, or you can solve for the sample size if you know what the minimum detectable effect is. This page here, slide 14, shows the formula for a continuous outcome, for example, looking at earnings in the post-program period. And there are two different versions of this one. One is when you have random assignment, and the one below, which is similar, but it has one extra term, is for when you have non-random assignment. And so I'm going to go through an example on the following page on how we apply these formulas. And I'm going to use a hypothetical example. Unfortunately, in translating an actual example I had used to the hypothetical for this webinar, I wrote up the slides as if we had a non-random assignment, as if we were using propensity score matching, but the formulas I used are actually for a case where we had random assignment. So these numbers that I'll be going through in the next couple slides actually apply to random assignment rather than propensity score matching. So, but I will correct the slides and change the spreadsheet shortly after we finish this. So in this example, assume we have 2,900 people in the treatment and comparison groups, combined with half in the treatment group and half in the comparison group. And we expect to have wage record data for the entire sample, so there's no attrition. And we'll set alpha at 0.05, power at 0.8, and use a two-tailed test. So then when we apply the MDE, we need a couple of other parameters, and this is where you evaluators will have to make some assumptions. First, we need an assumption for the R-square of the regression of earnings on the explanatory variable, and we also need to come up with an estimate of the standard deviation of earnings. And in the example, and I assume that it's 0.20, the R-square, and that's based on looking at literature for earnings functions that have been published in either evaluation reports for youth or dislocated workers, or in journal articles. So we could look in any of those places and try and pick an appropriate R-square. The most conservative assumption you could make is that the R-square is 0, that we can't really explain earnings very well. So then the second assumption, which is harder, is you need an assumption on what the standard deviation of earnings is. And in this case, I was looking at a youth program, so I used the values from the evaluation of the Job Corps, and there they found a standard deviation for earnings, the dependent variable, to be $4,899. So when I plug those into the spreadsheet, I come up with an estimated minimum detectable effect of $455.70. And what that means is that if the program's impact is at least $455.70, we have a good likelihood of obtaining a statistically significant impact finding when we estimate the impact with a sample of 2,900 people. And this next slide talks about some of the ways we can try and get a smaller MDE. It may be the case that this $455 is too big a number and that we expect the program to be less effective than that. Well, how could we get a smaller minimum detectable effect? One is, if you're not putting half the people in the treatment and control group, if you move it closer to 50-50, equal numbers in the two groups, that will help get you a smaller MDE. Another thing you can try and do is make sure you've got all the possible variables that are available to include in your regression on the determinants of earnings in addition to treatment status. And if you get the R-square higher, if you add more variables, that also lowers the MDE. The strategy you'd like to try, if you can, is to increase the size of the sample. For some of you, it's too late to do that, but for those of you who are doing propensity score matching, for example, you might be able to increase the sample size by, instead of picking one nearest neighbor, picking 2 or 3 or 5 nearest neighbors. So that's another way to try and look into ways to reduce the MDE. And then I point out you can also get a smaller MDE by increasing alpha, in other words, assuming 0.10 instead of 0.05, by decreasing the power or using a one-tailed test. But this is not a good strategy to use. Those parameters should be fixed before you do any of the research. And in the spreadsheet that you'll be able to look at later, I did some changing some of the parameters to try and see what difference it makes in our MDE, and this will give you an example. So remember, our original number was that the MDE is $455.70 in that final bullet. And now, suppose that our sample size falls by half. It's only 1,450 instead of 2,900. Well, that increases the MDE, but not as much as you might think. It goes up to $644. If we switch from 50-50 to 2/3, 1/3 in the composition of the treatment and comparison or control groups, That also increases the MDE, but not that much. It goes from $455 to $483. If we go to an R-square of 0, the extreme case where we can't really explain earnings, that raises the MDE from the 455 up to 509. So although other variables can help, they're not going to make that big a difference. And then finally, I also varied the parameters. I told you shouldn't change. If we change the alpha to 0.10, switch the power to 0.7, and use a one-tail test, the MD drops quite a bit to 293. This next one is a very telling slide. If we only have a sample of 400, the MDE goes up quite a bit to $1,227. So a small sample can really penalize you in these calculations, and that's why I'd urge you to try and get as big a sample as you possibly can. So then this last slide here has a summary of all the different findings. As I mentioned, the one these examples that I worked through today were for if you had random assignment. I'm going to change the PowerPoint and post ones where we do non-random assignment as well. So that concludes my presentation. We'll come back and answer questions later. I'll turn it back to Randy to introduce Greg.
Thank you, Bert. And next we're going to hear from Greg Compton, an evaluator of TAACCCT and our additional subject matter expert from the University of Texas Ray Marshall Center for the Study of Human Resources. And Greg?
Thank you, Randy. And Bert, I appreciate that introduction here. So essentially, I'm going to go through and discuss just some practical considerations as we go through the process of engaging in some of these power analyses. So power calculations, essentially, in my view, should be performed twice. At the beginning of the project to make certain that if the implementation and evaluation plans are executed just as they're written, the analysis will yield usable results. And then again, prior to performing the final analysis of results, just to ensure that any changes that have occurred in the sample sizes or other facts on the ground are considered prior to determining program effects. I think that a lot of evaluators for the TAACCT grants came in sort of in process, and so I think it's clear it's better to make the sense of thinking, imagine nothing has happened yet and perform the power analysis, and then wait till the end to perform another power analysis. So how you create these two power analyses differ. Essentially, at the beginning of the project, you're going to assume that all of the grant details will occur as stated, and hopefully they've been very clear as to who will be participating in terms of their numbers. You'll determine your preferred method of analysis, either experimental or quasi-experimental. You'll pull information needed for calculations from the literature, as Bert did earlier with the previous examples. And then just with those examples, you'll want to play with changeable aspects of the power analysis to inform responses to potential scenarios. Then you'll use that information to communicate with grantees to give them a sense of what the power might be for testing some of these things. And then a specific note, just to reiterate what Bert indicated before, decisions regarding alpha and where you set power and a one-tail versus two-tail test, this is when you should be making those decisions, and those decisions should not change when you perform the power analysis at the latter stages here. So, and then the power analysis that you'll be engaging in prior to performing the final analysis of results, you'll be using the actual data from the project that you have in hand because you've gotten everything that you've asked for, assuming. Then you will pull information needed for calculations from your data, the R-squared and the standard deviation of earnings, and you'll use results to be certain that the measured effects that you have are beyond the minimum detectable effect. Just a quick note about the power analysis sample size. As Bert mentioned, if you have the opportunity to get more individuals in your sample, that is, of course, for the best. But throughout the project, do you want to monitor the numbers of participants to ensure that targets are being met or exceeded? A lot of these programs are multiple years, and within each year they have certain targets, and it's a great way to sort of test, not test, but to see how well they are doing in terms of getting the numbers that they need. And then just a really quick note here, if you're using a propensity score matching with a lot of individuals and evaluators doing here, or regression discontinuity, you will likely reduce your sample size from both the control and the treatment groups. For propensity score matching, this is essentially because the distribution of the propensities to be in the program for the treatment and the control group may not perfectly line up, and so you will lose individuals from your sample because they won't be from your treatment group because they won't be matched to controls, and vice versa. My experience is that the sample loss can range from about 5 to 15%, and I like to consider that in my initial power calculations to be certain that if at the end it's not a surprise for me. I don't like that to be surprised by low sample size at the very end of this process. So the two examples I'll be discussing are both examples that are being evaluated through the Ray Marshall Center work here. The first is the Training for Regional Energy in North Dakota, the TREND project. They seek to provide training and education for jobs in industries that are benefiting from the Bakken Formation oil boom. So the demand for these jobs is incredibly high. It's so high that people may not even complete the programs, and they may be pulled early and still receive a benefit from the training that they have completed. And then the other program, the retraining of the Gulf Coast workforce through IT Pathways Consortium, the consortium project, which is in Louisiana and Mississippi. They intend to retrain workers for the IT workforce in local manufacturing and healthcare industries. And this is more a Trade Adjustment Act type of effort. These individuals have had their jobs moved abroad, and so they're needing to retrain to find something locally. So in terms of these examples, I'm just going to go step by step through these without paying too much attention to the calculations, because I think Bert's done an excellent job of discussing those. But I'm going to use the grant proposal to determine the outcomes that they're looking for. I will determine the minimum detectable effect of each of the binary and continuous variable outcomes using appropriate formulas. And here, what I like to do at this initial stage, which is not necessary at the very end of the process, but in terms of communicating with grantees, establishing sort of a best case, worst case scenarios. And here I've, just as an example, you may choose your own boundary points for best case, worst case scenario. I'm going to assume that the sample size is projected, that the loss due to using propensity score matching or regression discontinuity is just about 5%, and that the R squared is pretty good, it's 0.40. And then I'm going to do a worst case example where the sample size is reduced by about 10%. Just off the bat, they were not able to reach their targets. Loss due to propensity score matching is about another 15%. For some reason, there's difficulty in the matching. And then R squared is 0.10, which is not a very good explanatory power there. So for the trend projected outcomes, so these were items that were found in the grant specifically, so that they intend to serve about 1,500 participants over the course of the grant. About 61% are hopefully completing a funded program of study, 84% completing some credit hours, 63% earning credentials. They hope that 78% will be employed after the study completion, and then 28% will receive a wage increase. And essentially, these percentages are pi, or they're the proportion of the study population with a successful outcome in the formula that were presented early in the binary analysis. And so these are already there. So perform a power analysis for each one of these outcomes. I come up with a worst case scenario and a best case scenario in each instance here. And note that here, we're talking about a minimum detectable effect of between 4% and 3%, depending on the outcome that we are looking at. And then notice that I've added an additional line here, the measurable wage increase. The 2% there for participants who received a wage increase, that's really not very effective because you're not measuring what that wage increase would be. So looking at a continuous example of that with the measurable wage increase here, I see a best case scenario of being able to detect about a $400 and a worst case scenario about $507. And so communicate this, and I'll talk about that here in a second with your client, but considering the incredibly high demand for workers and even partially complete partially complete training in North Dakota, it seems reasonable that these measured effects will probably exceed these minimum detectable effects. So the Gulf Coast projected outcomes. Here, they have approximately 2,000 participants, and here we have about 85% will need to be completing a funded program of study. Part of this is that and it's a little higher here than it was in North Dakota, because in North Dakota they expect individuals to be poached. But here, in order to receive the benefit, you need to receive a certificate. As a benefit from the training, you need to receive a certificate or to complete the program of study. Note that, and these are very similar to the setup before, but note here the total number of participants earning credentials. What they've actually reported in this case is the number of credentials that will be awarded to all participants, and so they're assuming that people will be receiving multiple credentials, and so I really cannot perform a power analysis without going back to the client on that number and figuring out what they're really seeking for that. And so these were included in the outcome projections. And again, once again, a worst case scenario, best case scenario between here. Because we had the larger sample size of about 2,000, we have a difference of about 3% or 2% for a minimum detectable effect. And for the measurable wage increase, we have about 350 and about 450. And note that these would be average effects. All of these programs are, at least for both Trend and the Gulf Coast, they are engaging in multiple sort of veins of training. So in Trend, there's some welding work, but there's also some power plant work. If the sample, right now I'm not testing for the sample size for each of those different groups. I'm looking at the overall effect of the program to get a general sense of its effectiveness, partially because the numbers would, for each of those individual programs, would likely be too low to have enough power to really test for statistical significance. So the next steps here, once I've calculated the minimum detectable effect with at least 2 reasonable scenarios, I usually communicate that with any client, or in this case, the TAACCCT grantees, and essentially ask, do they already, at the beginning of this process, foresee any changes in the sample size? Because they might, something might have changed. And also, whether they expect their outcomes to be the same. Many things happen as you try to build these programs from scratch in some cases, and so they may have encountered some issues that they did not imagine they would have, securing a teacher to teach a particular course, and so their outcomes may be shifted consequently about their expectations. And then also, whether the expected wage increase amounts are close to really what they expect, the wage increase for participants. And so hopefully they should sort of comfortably exceed those that you've calculated. And this is just a general sense of their belief in some ways, but it can be helpful in guiding where you move from there. And then if they already think the sample sizes or the outcome numbers are likely to change, I simply recommend going through, doing one more round of power analysis, make those changes just to make sure that, and determine what 2 new minimum detectable effect scenarios might be for them. And that is it. So I appreciate your time. I appreciate it. Here for questions if you have them.
Thank you very much, Greg, for that helpful presentation. So we're in the point now where you can ask questions of the subject matter experts. You can raise issues or offer examples of work you're doing with power analysis, dealing with small sample sizes, programmatic or other changes to beef up your sample size, or things you've encountered that affect your sample size in your program. But we've got a great team here to answer your questions and entertain discussions. So let us know. We can you can type your question in chat box.
Yeah, feel free to use chat box at the bottom right of your screen, and we'll make sure to repeat the question, and then one of our presenters or Randy here will hop in and answer your question.
Okay. Greg just mentioned that merging programs of study to get a larger sample is something that's done. Is this common? In the course of evaluations?
I can certainly answer that. It depends on what you're doing in your capacity. So naturally, you really would like to evaluate every program individually, the welding program. But in this case, because we have such a small number of individuals, and these programs are really designed, at least in these individual ones that we're working about, to increase sort of the capacity of these colleges to improve their stacking credentials and having employer engagement, and so that may have, the overall effect of that sort of programmatic effect within the campus could have an effect on individuals, and so that's why we sort of group it together.
Yeah, let me address that also. It depends on the circumstances. In terms of getting a smaller minimum detectable effect, you're always better off with the larger sample, so pooling helps. What the bad part about pooling your across programs is you don't know whether the impact you're getting is the same in both programs, or one of them is really good and the other one isn't, and so on. So you won't be able to answer quite the same questions. So it's important to think about the trade-offs that are involved and which questions are most important.
And I would think, just adding from my perspective, you have to look at the similarity or dissimilarity of the treatment if you're combining programs.
Right, it means less if you're combining things that are much different. The other thing that could be a problem, and this is going on in a different study I'm working on now for the Department of Labor, if the control groups or comparison groups are getting much different types of situations, then you're not making the same comparison to people who aren't getting the treatment, and that can make it difficult to interpret as well.
We have a question about working with extremely small sample sizes, even as small as 5 to 12 participants, and comparison groups of similar size. Is there any benefit to doing any statistical analysis besides the presenting frequencies, presenting the findings?
Well, I think you can do the statistical test, but you should put in strong caveats that with small samples, and indeed in training programs, often with fewer than 400, often you just don't have enough statistical power to get statistically significant findings. And so you need to warn the readers not to be concerned if you don't get significant findings. It doesn't mean that the programs aren't effective. It just means you didn't test them in a way where you'd be able to find that out. And I mean, there's a lot of problems that occur where people misinterpret an insignificant finding as meaning that there's no impact, and those are not at all the same thing. And indeed, that's one of the benefits of doing the MDE. If you do these minimum detectable effect calculations and you find that you'd need an impact of, say, my guess would be if you plug in the numbers of 12 in each group, you'd need a huge effectiveness to get significant findings, and you're not going to usually have that. So this will alert you not to expect significant findings, and to tell your sponsors and to tell your policy audience that this was set up to test out a particular intervention. That's why we did it. We don't have enough people to really learn with any certainty whether it's effective or not.
Greg, do you want to add anything to that?
No, I mean, honestly, that was well stated. That's great.
We have a similar question, particularly related to rural institutions with small programs. Is there an absolute minimum sample size for valid use of power analysis?
I would say no, because the power analysis lets you know that you have a problem and that you should not look to find significant findings. So it's always a good idea to try it out and be warned. I would like to give an example where a relatively small samples led to a major change in workforce policy. That was back in the 1970s, where the first job club studies were done, and they only had about 60 or 80 people. The studies were done by a professor at Southern Illinois University, and I think that was all he could afford to look at. But the impacts were so large that he got statistically significant findings. Typically, when you're looking at a training program, things like that, you're not going to get significant findings with less than 400. But it's better to know that, and that way you can warn people not to misinterpret your findings.
Okay, that's helpful. Further questions from folks in the audience? Any experiences you'd like to share of doing this kind of analysis or troubleshooting for small samples, techniques you've used to increase the power or MDE in your own analysis?
I mean, I can definitely address that. Bert had mentioned earlier, you know, one of the things that you do if you're using propensity score analysis is you can choose additional comparison group members. And so if you, instead of having just a 1-to-1 ratio, which is what I've used in my calculations there, you could have a 1-to-2. You can find other comparisons. And you can significantly increase the power, but you do want to be careful with that because the more individuals that you pull in, it's potential that you could pull in some bias, and so you just have to balance a little bit of that out. So
right.
Just be cautious.
I would agree.
One of the things that we heard when we put out a call to people in the people who registered for the webinar was any questions or experiences they had had. And one of the things that came up was the issue of programs being modified either by decisions from the funder or within the college or other contingencies like that that either increased or decreased the sample size. So if anyone has further experiences of that, that would be helpful. We have another question. An evaluator who's looking at 2 different grants, one with 500 in the sample and 500 in a historical cohort. The other one has approximately 500 in the sample, but no historical or same-time comparison available. Should she start to prep the client for other options to propensity score matching? They are convinced they have to do this, that it's required of them.
I'm not sure I understood the question. Were they saying that they have a good comparison group for one of the cohorts but not for the other one?
Yes, they lack a historical or concurrent comparison group, and the question is, should they abandon propensity score matching, you know, in that instance? I would assume if they don't have a sample, at least for that obviously they can't do it. The other one I can't say.
Yeah, it sounded from the question you read like in one case she can do a good analysis and so she should proceed. But in the case where there's no reasonably good group, she may have to just do an outcome analysis, which I believe the SGA said is one of the acceptable ways to do the analysis. You just won't be able to even address the issue of what would have happened without the training, without this intervention.
Additional comments or questions? Greg or Bert, do you have other experiences do you think would be valuable from programs previous to TAACCCT in your professional history that might illuminate the kinds of things people are going to run into?
Well, I would just mention briefly that I worked on a national evaluation with some of the other people on our team, with Lauren Eister in particular, and we had to use propensity score matching to evaluate a training program where when the demonstrations were funded, there were no plans to do an impact evaluation, and that requirement got added later by the Office of Management Budget. So by the time we tried to do the impact evaluation, we were stuck with samples that were quite small, and we didn't have a lot of variables we could use for coming up with a good match. And we warned the Department of Labor, and they understood this. And so what we did was in our report, we put in a lot of caveats saying that even though we didn't obtain statistically significant findings, that doesn't mean these weren't good programs. And I felt we were able to keep our integrity by pointing out the limits, and at the same time helping people not to misinterpret the findings and think that these were necessarily bad programs. It's just that there was no planning that went into it at the beginning to make sure we'd be able to do a good evaluation.
Lauren, you had an additional comment. Lauren Eister?
Sure. I just wanted to address the comment about you know, moving more towards an outcome analysis, you know, something without a comparison group. And I think it's something your grantee should, you know, work with their FPO on, and you know, just making sure that it's, you know, something that the department says is okay. It's not something that we as the evaluation team can do. But I mean, I think it's also important to think about ways that maybe you could benchmark what you're learning, you know, for your TAACCCT participants. You know, if there are some comparisons that you can make to, you know, put some context around what these outcomes are and how well maybe the students are doing. I think that's helpful to do, so you have some way to say whether you think there's some at least promising or challenging results. But again, you know, I think Bert is right in being really cautious in how much you would oversell any findings like that. But you know, I think it's just always good to at least be able to put some of the findings and results in context.
Thank you, Lauren. Are there any other questions or comments from the audience? At this point, we'll start wrapping up. If not, Bert or Greg, would you like to get a last comment in, or anything you might have missed to advise our audience?
No, just to point out that if they aren't that familiar with this, they should take a look at the material that we're going to post on the SharePoint site and look at some of the articles and books. Okay,
well, I want to thank our subject matter experts, Bert Barnow and Greg Compton, for their excellent and rich material today. It's a lot to get your head around, but as Bert said, there's good resource materials on the SharePoint site. We're going to post the PowerPoint there as well. And just in terms of coming attractions, stay tuned. We're going to have several more virtual roundtables on topics of interest in the next several months, as well as an additional webinar on topics to be determined. So thank you for tuning in, and we'll talk to you later.
Thank you.
Thank you.
Thanks.